Hello class, we're doing problem set 3, number 1. We have a bucket filled with water attached to a string and we're spinning it in a circle on a vertical plane. And we're looking at the instant that it is right above our heads when it's upside down. So what's given? We have mass equals 2 kilograms, the velocity is 6 meters per second, and the radius is 2 meters. Okay, and so what do we know for sure? We know that net force is equal to mass times acceleration. And we know it's moving in a circle, so we know that there is a centrifugal acceleration towards the center. So what are the only two forces acting on it? It's tension and the force of gravity. So you can see here that this equals tension minus gravity. So we replace acceleration with this equation. Centrifugal acceleration equals v squared over r. When we plug in everything, it's 2 kilograms. We plug in 6 meters per second with a radius of r. And we're looking for tension of the string minus 2 kilograms times the gravitational constant negative 10. So what you get is 36 equals t plus 20, and you minus 20 on both sides, and t equals 16 newtons. Part 2 is asking what is required for the water to stay in the bucket while it's overhead. So we're looking for the sum of the forces, the speed, and the acceleration possible for it to stay overhead. So we have that same equation up top, but this time t equals 0 because say it does not stay overhead and the water does fall out. For that to happen, the tension would have to be 0, and that's a result of you not spinning it fast enough. So tension equals 0. Just plug everything in to find the sum of the forces with tension 0 times the gravitational force, and that equals 20 newtons. And then we're trying to look for the acceleration now. With 2 kilograms, the acceleration is 10 meters per second. And now we're looking for the velocity. We know that with centrifugal acceleration equals v squared over r. And so 10 equals v squared over 2. Square root 5 equals v, essentially. And so I approximated that to 2.25. So what we're looking at here is what is required for it to stay overhead. So if you spin it super fast, it's still going to stay overhead, just because as long as it's over these numbers. So it's just, so to reiterate, the force must be over 20 newtons, the acceleration must be over 10 meters per second, and the velocity must be over about 2.25 meters per second. And that's the whole problem. Thank you.